In number 5, we're going to look at a revenue function. So let's quickly talk about what revenue is. Revenue is the amount of money that like a business brings in. So we often use a capital R, and we'll say like R of X for a revenue function. Well, the money you bring in is equal to like the price per item times the quantity of items. So like if I'm selling t-shirts, I sell them at $10 a piece, I would do $10 times however many I sell. If I sell 50 of them, to figure out that the revenue I brought in is $500. Now that's not necessarily my profit. It's just the money I bring in. Okay, so a go-kart track has about 380 racers per week. So this is quantity. I'm going to highlight anything in quantity in blue. And charges about $35 to race. The owner estimates that there will be 20 more racers per week for every $1 reduction in the price per racer. All right, so we're going to write a revenue function. But I got to think about what my unknown is first of all. So I'm going to say X is my unknown like I normally do, but what does it represent? It's, well, they're changing the price. So it's the number of times the price is changed. Number of price changes. All right, so my revenue function, I'm going to say R of X is equal to, I open up 2 sets of parentheses, large enough to do a little bit of math here. So normally, okay, so if I do price first and quantity second, you'll see it flip-flopped. It doesn't really matter. You could do quantity times price. Just keep your numbers straight. So the price is $35 and 380 racers show up, right? 35 times 380. But then they figure out if they adjust it. How do they adjust it? Well, they're dropping the price, $1 reduction. So minus 1, but they don't just drop it one time. How many times do they drop it? We don't know. So 1 times X. What happens to the amount of racers? Well, the racers, more people show up. So I'm going to add how many? 20 each time they change the price. So plus 20X. Some things to notice. So in these revenue functions, I got one that's a minus and one's a plus. You will always have that. All right, so there it is. What I want you to do now, though, is change this to standard form. So you're going to need to do some distributing to get that done. So I zoomed in here to give myself a little more space. What I need to do is distribute the 35 to the 2 things in the second set of parentheses. So to change it to standard form, this is going to be 35 times 380. And that is 13,300. And 35 times 20x would be plus 700x. And now I need to distribute this -1 to both things. So this will be negative 380x and then minus 20x squared. Okay, so standard form here would be put the x squared first, so negative 20x squared. I'm going to combine my middle terms, is positive 320x, and then it's plus 13,300. Okay, there is my revenue function in standard form. Determine the price that will maximize the revenue. Okay, so maximize. My A value is negative. What's that tell me? It tells me my parabola opens downward. So here's the highest it's going to get. So I need to find my vertex. All right, so what are we going to do? We're going to do negative B over 2A, which is equal to negative 320 over 2 times negative 20. Quickly do that math, and I get 8. So my x-coordinate is 8. How do I get my y-coordinate? I need to do R of 8. So if you just pick up your calculator and plug in 8, gives me 14,580. Okay, so let's just take a second and say what these two things mean. So X was my price changes. So this means if I change the price 8 times, 8 price changes, will give me a revenue, because y, or the r of x is the y, is the revenue. But what does part B ask me? It says determine the price that will maximize the weekly revenue. Easiest way to get this, there's more than one way, is look right here at the beginning equation. The price was equal to 35 minus 1x. So if you just take this price expression right here and you plug your x value in, so 35 minus 1x, and you just found that x is 8 when it's maximized at the vertex, so you just plug it in to get 35 minus 8 is $27 would be my answer to part B. Now part C, what is the maximum weekly revenue? We have that already. That's in our ordered pair. We labeled it as the revenue. So if they change their price 8 times, they're going to maximize their revenue, bringing in $14,580. Let's continue your notes by looking at some revenue functions. Okay, this next one's about Mrs. Houck and her Spartan race in Vermont last year. On the fire jump obstacle at the 2019 Spartan race in Vermont, Mrs. Houck's jump could be modeled by that function. Very similar to the jump of a red kangaroo, only with much more elegance and grace. Where x is the horizontal distance in feet covered by Mrs. Houck, and y is her height in feet throughout the jump. If the flames reached a height of 4 feet, did Mrs. Houck complete the obstacle uncharred? Well, if she's jumping, her path is going something like this. Okay, so what do we need to see? Does her height get up to a y value of 4 feet? Okay, does it reach 4? If it does, she didn't get burned. So what do we need to do? Let's find our vertex. So when I plug in, I get an x value is 14, and I now have to plug in 14 in for my x to get my y. And when I do that, I get y equals 6. So if this is the vertex, she reached a height of 6, that means she would have made it over the flames without being charred.